We're up to a very exciting point in evaluating our machine learning model, and that is visualizing, visualizing, visualizing. And we saw that in the previous video, our model kind of gets a little bit confused, and in fact, I would personally get confused at the difference between t-shirt/top and a shirt. So these kind of insights into our model's predictions can also give us insights into maybe some of our labels could be improved. And another way to check that is to make a confusion matrix. So let's do that. Making a confusion matrix for further prediction evaluation. Now, a confusion matrix is another one of my favorite ways of evaluating a classification model, because that's what we're doing. We're doing multi-class classification. And if you recall, if we go back to section 2 of the Learn PyTorch.io book, and then if we scroll down, we have a section here, more classification evaluation metrics. So accuracy is probably the gold standard of classification evaluation. There's precision, there's recall, there's F1 score, and there's a confusion matrix here. So how about we try to build one of those? I want to get this and copy this. So, and write down a confusion matrix is a fantastic way of evaluating your classification models visually. Beautiful. So we're going to break this down. First of all, we need to plot a confusion matrix, we need to make predictions with our trained model on the test data set. Number 2, we're going to make a confusion matrix. And to do so, we're going to leverage torch metrics. Tricks, had to figure out how to spell metrics then. Confusion matrix. So recall that torch metrics, we've touched on this before, is a great package. Torch metrics for a whole bunch of evaluation metrics of machine learning models in PyTorch flavor. So if we find, we've got classification metrics, we've got audio, image detection. Look how, this is beautiful. A bunch of different evaluation metrics. And if we go down over here, we've got confusion matrix. So I only touched on 5 here, or 6. But if you look at torch metrics, they've got, how many is that? About 25 different classification metrics. So if you want some extra curriculum, you can read through these. But let's go to confusion matrix. And if we look at some code here, we've got torch metrics, confusion matrix. We need to pass in number of classes. We can normalize if we want. And do you notice how this is quite similar to the PyTorch documentation? Well, that's the beautiful thing about torch metrics, is that it's created with PyTorch in mind. So let's try out. If you wanted to try it out on some tester code, you could do it here. But since we've already got some of our own code, let's just bring in this. And then number 3 is to plot it. We've got another helper package here. Plot the confusion matrix using MLExtend. So this is another one of my favorite helper libraries for machine learning things. It's got a lot of functionality that you can code up yourself, but you often find yourself coding it a few too many times, such as plotting a confusion matrix. So if we look up MLExtend, plot confusion matrix, this is a wonderful library. I believe it was created by, Sebastian Rushka, who's a machine learning researcher and also author of a great book. There he is. Yeah, this is a side note, Machine Learning with PyTorch and Scikit-learn. I just got this book. It just got released in the start of 2022, and it's a great book. So that's a little side note for learning more about machine learning with PyTorch and Scikit-learn. So shout out to Sebastian Rushka. Thank you for this package as well. This is going to just help us plot a confusion matrix like this. So we'll have our predicted labels on the bottom and our true labels on the side here, but we can just copy this code in here. Link, sorry, and then confusion matrix, we can copy that in here. The thing is that torch metrics doesn't come with Google Colab. So if you're using Google Colab, I think MLExtend does, but we need a certain version of MLExtend that Google Colab doesn't yet have. So we actually need version 0.19.0. But we're going to import those in a second. Let's first make some predictions across our entire test data set. So previously, we made some predictions only on 9 random samples. So random sample, we selected 9. You could, of course, change this number to make it on more, but this was only on 9 samples. Let's write some code to make predictions across our entire test data set. So import tqdm.auto for progress bar tracking, tqdm auto. We don't need to re-import it, I believe we've already got it above, but I'm just going to do it anyway for completeness. And so we're going to make, this is step 1. Above, make predictions. Make predictions with trained model. Our trained model is model 2. So let's create an empty predictions list so we can add our predictions to that. We're going to set our model into evaluation mode, and we're going to set with torch inference mode as our context manager. And then inside that, let's just build the same sort of code that we used for our testing loop, except this time we're going to append all of our predictions to a list. So we're going to iterate through the test data loader, and we can give our tqdm description. We're going to say making predictions, ... You'll see what that looks like in a minute. And here we are going to send the data and targets to target device. So x, y equals x to device and y to device. Wonderful. And we're going to do the forward pass. So we're going to create y-logit. Remember, the raw outputs of a model with a linear layer at the end are referred to as logits. And we don't need to calculate the loss, but we want to turn predictions from logits to prediction probabilities to prediction labels. So we'll set here ypred equals torch.softmax. You could actually skip the torch softmax step if you wanted to and just take the argmax of the logits, but we will just go from prediction probabilities to pred labels for completeness. So squeeze, and we're going to do it across the first dimension, or the 0th dimension, and then we'll take the argmax of that across the first dimension as well. And a little tidbit, if you take different dimensions here, you'll probably get different values, so just check the inputs and outputs of your code to make sure you're using the right dimension here. And so let's go put predictions on CPU for evaluation, because if we're going to plot anything, matplotlib will want them on the CPU. So we're going to append our predictions to ypreds, ypred.cpu. Beautiful. And because we're going to have a list of different predictions, we can use concatenate, list of predictions, into a tensor. So let's just print out ypreds, and so I can show you what it looks like. And then if we go ypred tensor, this is going to turn our list of predictions into a single tensor. And then we'll go ypred tensor, and we'll view the first 10. Let's see if this works. So making predictions, oh, would you look at that? Okay, so yeah, here's our list of predictions. A big list of tensors. Right, we don't really want it like that, so if we get rid of that, and there's our progress bar. It's going through each batch in the test data loader, so there's 313 batches of 32. So if we comment out print ypreds, this line here, torch.cat ypreds, is going to turn these tensors into a single tensor, or this list of tensors into a single tensor. Concatenate. Now if we have a look, there we go, beautiful. And if we have a look at the whole thing, we're making predictions every single time here, but that's all right. They are pretty quick. There we go, one big long tensor. And then if we check length ypred tensor, there should be one prediction per test sample, 10,000, beautiful. So now we need to install Torch Metrics, because Torch Metrics doesn't come with Google Colab at the time of recording. So let me just show you if we try to import Torch Metrics. It might in the future, so just keep that in mind. It might come with Google Colab because it's a pretty useful package. But let's now install, see if required packages are installed, and if not, install them. So we'll just install Torch Metrics. We'll finish off this video by trying to import. We'll set up a try and accept loop. So Python is going to try import torch metrics and ML extend. I write it like this because you may already have torch metrics and ML extend if you're running this code on a local machine. But if you're running it in Google Colab, which I'm sure many of you are, we are going to try and import it anyway. And if it doesn't work, we're going to install it. So ML extend, I'm just going to check the version here because we need version for our plot confusion matrix function. This one, we need version 0.19.0 or higher. So I'm just going to write a little statement here. Assert int ML extend dot version. So if this condition in the try loop or try block is accepted, it will skip the next step. Dot split, and I'm just going to check the first index string is greater than or equal to 19. Otherwise, I'm going to return an error saying ML extend version should be 0.19.0 or higher. And so let me just show you what this looks like. If we run this here, string and int. Did I not turn it into a string? Oh, excuse me. There we go. And I don't need that bracket on the end. There we go. So that's what I'm saying. So this is just saying, hey, the version of ML extend that you have should be 0 or should be 19 or higher, because right now Google Colab by default has 14. This may change in the future. So let's finish off this except block. If the above condition fails, which it should, we are going to pip install. So we're going to install this into Google Colab. Torch metrics, we're going to do it quietly. And we're also going to pass the U tag for update ML extend. So import torch metrics, ML extend afterwards, after it's been installed and upgraded, and print. We're going to go ML extend version. Going to go ML extend underscore version. And let's see what happens if we run this. So we should see, yeah, some installation happening here. This is going to install torch metrics. Oh, do we not have ML extend, the upgraded version? Let's have a look. We may need to restart our Google Colab instance. Ah, okay. Let's take this off. Quiet. Is this going to tell us to restart Google Colab? Well, let's restart our runtime. After you've run this cell, if you're using Google Colab, you may have to restart your runtime to reflect the fact that we have the updated version of ML extend. So I'm going to restart my runtime now. Otherwise, we won't be able to plot our confusion matrix. We need 0.19.0. And I'm going to run all of these cells. So I'm going to pause the video here, run all of the cells by clicking run all. Note, if you run into any errors, you will have to run those cells manually. And then I'm going to get back down to this cell and make sure that I have ML extend version 0.1.9. I'll see you in a few seconds. I'm back, and just a little heads up, if you restart your runtime and click run all, your Colab notebook will stop running cells if it runs into an error. So this is that error we found in a previous video where our data and model were on different devices. So to skip past that, we can just jump to the next cell and we can click run after. There we go. And it's going to run all of the cells after for us. It's going to retrain our models. Everything's going to get rerun, and then we're going to come right back down to where we were before, trying to install the updated version of ML extend. I'm going to write some more code while our code is running. Import ML extend, and then I'm going to just make sure that we've got the right version here. You may require a runtime restart, you may not. So just try to see after you've run this install of torch metrics and upgrade of ML extend. See if you can re-import ML extend, and if you have the version 0.19.0 or above, we should be able to run the code. Yeah, there we go. Wonderful. ML extend 0.19.0, and we've got ML extend version, assert, import. Beautiful. So we've got a lot of extra code here. In the next video, let's move forward with creating a confusion matrix. I just wanted to show you how to install and upgrade some packages in Google Colab if you don't have them. But now we've got predictions across our entire test data set. And we're going to be moving towards using Confusion Matrix function here to compare our predictions versus the target data of our test data set. So I'll see you in the next video. Let's plot a confusion matrix.